So we have reversed linked list. Given the beginning of a singly linked list, reverse the list and return the new beginning of the list. So a singly linked list just means that at each node, it has a pointer to go to the next node. And this is in contrast to doubly linked list, where each node not only has a pointer forward, but it also has a pointer backward. But that's not what we're working with today. We're working with a singly linked list. And we want to reverse the list and also return the new beginning of the list. So our ideal state would look something like this perhaps, where 3 will be pointing to 2, 2 will be pointing to 1, 1 will be pointing to 0, and 0 will be pointing to nothing. Well, technically in our original list, our last element 3 also points to nothing. In Python, that's just none, right? So effectively what we're doing is kind of flipping this arrow. We kind of flip it over here, it goes like that. This one, flip it here, and so on and so forth, right? And that's how we get our answer here, and we want to return this. So okay, say we have a pointer called current, and that's just going to start at this element. And as you know, each node class has a value, which is their number, and it also has a next, which points to another node. So with this setup, cur is a variable of type node, and I can do like cur.val, cur.int, or whatever, right? So if I want to flip this arrow, then I have to say cur.next is equal to the previous element. Well, we don't really have a previous element, so I could just put none, but that's not always true, right? Like if current is here, then we need to flip this arrow and make it point over here. And this is clearly not none. This is an actual node. So we kind of need a new pointer. I'm just going to call it prev, and prev just kind of points to none right now, right? So that's kind of convenient. We can point this arrow over here. And now we're one step closer, except we've got one small problem. When I pointed this arrow to the previous value, I kind of severed the link to go to the next node. I can't access this anymore. And the solution would be to first set up a new variable called next. I'm just gonna spell it like this. And so when I flip this, by running this line, I can still increment my current to the next one. All I have to do is say cur is equal to next, right? And by doing that, I can move that here. But of course, before we do that, we need to update our previous value. Prev has to first move to current. So prev would go here, current will go here, and then next, well, before we change this arrow again, we want to move it to current.next. And you can see that this is kind of the same thing. This is the same state as we had just now. Then this is probably some kind of while loop where we change this arrow, move the prev here, and then we move current, and then we move next. And for our last loop here, we run this line as usual, which points the arrow. We move the prev over here, move the current here. And then for this line, well, right now our current is none, right? So if we do none.next, this is going to throw an error. So we can't have that. We probably need an if check here just to make sure current is not null. And in this last one, because it's null, this doesn't execute, so it doesn't error. And then we break the while loop since we're going to keep going while current is not none. And then since current is none now, I'm going to return prev, since prev is pointing at the head of the reversed list. So what about the initialization? Well, in our input, we're going to get a head variable, which is of type node. And this head pretty much points at where the first element is. So we can say current is equal to head. Prev starts at none. And as for next, it can be current.next, right? And then we handle the edge case. What if it's empty? What if it's a single element? If it's a single element, then this initialization will fail, right? If it's just one element, then we just want to return it as is. We don't really have to reverse that. And similarly, if it's empty, we can just return it as is, right? So just to handle the final edge cases, probably in the very beginning, before we even do any initialization, we check if head is none or head.next is none, right? I am out of space, but you get it, right? You get it. And then we just return head. That's it, fellas. Let's copy paste the code. So edge cases in the beginning, we have if head is none or head.next is none. If either one of this is true, then we just return head, right? And then we can do our initialization, our current. I'm going to set it to the head that we're given, and then we're going to say prev is equal to none, and then next is equal to current.next. And that's everything initialized. We need a while loop that keeps going while current is not none. Then we want to point the arrow to the previous element, and once that's done, we can update the prev pointer and move it to current. You can update the current pointer and move it to next. And if current is not none, then I'm going to move next to current.next, and then we return prev at the end. Yeah, and that works. So this looks a bit ugly, so I'm gonna move this code up here and just get rid of this. So the initialization is going to happen the very first thing. Try again. Much cleaner. And that's about it, fellas. Time complexity, this thing, we're processing every element one time. It's linear. It's pretty pretty linear. Space complexity, not really using any extra space. We just have pointers and each pointer just points to a single node. So yeah, O of n and O1. Thanks for watching. Okay, bye.